Hello students, welcome to section 1-3, distance and midpoints. We're going to take a look at the distance between 2 points to start, a distance on a number line. So let's say you have point A as x sub 1, point B is x sub 2. The distance between point A and B, in other words AB, is equal to the absolute value of x sub 1 minus x sub 2, or the absolute value of x sub 2 minus x sub 1. It turns out that you can take the difference of either one or the other, no matter the order. As long as you do the absolute value, you're going to find the distance between the two. The distance in the coordinate plane, the distance formula, as you may recall from Algebra 1, is equal to the square root of the difference in x2 minus x sub 1 squared, plus the difference in y sub 2 minus y sub 1 squared. So if you know two ordered pairs, you can do this very simply. And even if you flip-flop the order, as long as you flip-flop the order of both in context such that x sub 2 and y sub 2 come first or both second, you still will be squaring the difference, which in turn then ends up being a positive number anyways. And then you add them, square root them, and you get a positive answer. In some cases, the answer will be a nice number. In some cases, it will not. It will be irrational versus rational, which we'll see here in a little bit. Example 1. Use the number line to find the distance between A and B, or just segment AB is another way to say it, the measure technically of the segment. So A is at -4, B is at 2. I've already designated that the distance from 0 to -4 is 4, and the distance from 0 to 2 is 2. The absolute value of the difference between -4 and 2, if you were to flip-flop these, in other words 2 minus a -4, you would get the same end result. So in this case they get the absolute value of -6, which of course is 6. However, if you did the opposite operation, or the flip of the two terms or values, you would get 2 minus a -4, which is +6 of course, and still end up getting +6. A distance cannot be negative. And literally if you just count the distance from 0 to A and 0 to B, you still see of course 4 and 2 are going to add nicely to 6. Not a big surprise. Example 2. Find the distance between A, which is at -2, -1, and B, which is at 1, 3. I do encourage that you graph this on an XY axis on your own later. As it turns out, if you call this first point x sub 1, y sub 1, and the second point x sub 2, y sub 2, you'll be taking the difference of x sub 2, which is 1, minus x sub 1, which is -2, so 1 minus a -2, quantity squared, or of course what, 3 squared, and then plus 3, right, minus a -1, quantity squared, or 3 plus 1, which is 4, quantity squared. 3 squared of course is 9, 4 squared 16, add the 2, you get 25, the square root of which ends up being 5. This is a nice answer in that it's rational as opposed to irrational, and that's because of course 25 is a perfect square. If you were to have flipped these two numbers, you're still going to get 3, technically -3 if you think about it, but squared is still 9. Flipping these two numbers is going to give you -4, but quantity squared is still 16. So you'll still get 25 as a radicand, and then 5 of course as the distance. The distance formula, just to kind of speak quickly about another kind of application to think about, the distance formula is actually a version of the Pythagorean theorem. I mean, you can kind of see that here. Let's say maybe if I were to connect A straight across, let's say to this point, and that point up to B. So this right here would form a right triangle. So this height and this base of the right triangle has in turn then a hypotenuse of whatever that segment ends up being, using a squared plus b squared equals c squared. C squared being, or c for that matter, being the distance if you were to use the distance formula in context. So in theory you can use the Pythagorean theorem in place of the distance formula. It's just a different version. The next little set of problems, the exercises, I've done 1 and 6. I encourage you to practice some of the others on your own. The answers are available if you look down at the content library right here where it says answer keys. I encourage you to take a look at that on your own at some point for sure, and give yourself more practice for sure. But I try to pick and choose, like always, some really good questions that challenge you and get the basic points across still. So for number 1, it says you will use a number line to find each measure. BD, if you take point B, which is at looks to be -7, to point D, which looks to be at -1, you take -7 minus a -1. Take the absolute value of -6, of course, you get +6. Or if you do -1 minus a -7, you'll get 6, the absolute value of which is still 6. So the distance between those 2 points simply is 6. It cannot be negative, nor will ever be negative. For number 6, same idea, from point A at -9 to point G at 8. Let's start with 0 actually, all the way to -9, that's 9 units. And then from 0 all the way to 8 in the other direction, so 0 to 8 being 8, 0 to -9 being 9 units, 9 plus 8 of course being 17 units, and that's another approach that I strongly urge you to try, and try on the other questions for sure. But of course you can still subtract like we saw here, and just use the absolute value accordingly, in whatever order you want. Find the distance between each pair of points. So for number 9, if you do the square root of 6 minus 0 quantity squared plus 8 minus 0 quantity squared, you'll get 100, the square root of which of course ends up being 10. I do encourage that you graph this and take a look at the ordered pairs. This ends up actually being, if you kind of reflect back to your Algebra 1 days, using Pythagorean theorem, more specifically a special kind of right triangle called a 3, 4, 5. It's a 3, 4, 5 right triangle times 2. So if you multiply 3, 4, 5 times 2, you get a 6, 8, 10 as the hypotenuse right triangle. Kind of neat. Number 16, same premise. I went ahead and took -4 minus -2. -4 minus -2 or plus 2 is -2. So you have -2 quantity squared, which is 4. 3 minus 10. That ends up, of course, being -7. That squared being 49. So you have 49 plus 4, and that ends up being 53. 53 is not a perfect square, nor does it have factors when you break down the factor tree, factors of which are perfect squares. So 53 being a number you cannot break down any farther, the square root of 53 being the distance between these 2 points. Again, graph it. If you try the Pythagorean theorem on this one, this particular irrational number is the length of the hypotenuse of the right triangle that you can draw. It's just, of course, something that even a picture won't totally make clear in context. If you try that, great. The next page, you can see here the midpoint of a segment. Midpoint on a number line. If the coordinates of the endpoints of a segment are x sub 1, x sub 2, then the coordinates of the midpoint of the segment is x sub 1 plus x sub 2 over 2. So we're going to be taking a look at midpoints, not just algebraically, but also graphically. But let's go ahead and move on to a midpoint on a coordinate plane, in other words, an xy axis. If a segment has endpoints with, again, x1, y1, and x2, y2, you're not just taking x sub 1 plus x sub 2 and dividing it by 2. In other words, an average. You can think of it that way. You're also doing it with the y coordinates. So for the first example, you can see it says find the coordinate of the midpoint of segment PQ. So here's P at -3. Here's Q at 1. Those, as they say, are the coordinates. If M is the midpoint of PQ, so halfway between, quite literally in between P and Q, and I already can kind of see here it should end up being at -1, but let's do the math to prove our assessment. Then the coordinates of M should be the 2 numbers added, so -3 plus 1, and yes, you've got to use the sign. If in fact there is a negative, you got to use that. So -3 plus 1 divided by 2, so you're averaging the 2 values. In the numerator you get -2, you're dividing it by 2 always for midpoints, and therefore -1 indeed is the midpoint in between P and Q. For example 2, and no, this one is not graphed. If you ever want to graph to get a better perspective on midpoints, and certainly from the prior page on distances, I encourage that. For this problem I won't do that, but it says find the coordinates of M, the midpoint again, but of PQ such that this is one point and this is another. According to the formula up above, we'll add the x coordinates divided by 2. We'll add the y coordinates divided by 2. In this particular case, -2 plus 4 divided by 2. That's nice. That's 2 halves, or 1. 4 plus 1 divided by 2. So 5 divided by 2, or 2.5. So literally the midpoint between those 2 points, and again, if you were to graph it, you'd see, would be 1, 2.5. No needed graphing, but it is, again, like I said, a nice kind of finishing touch if you'd like. Moving on. So we'll do numbers 1 and 6. It says use the number line to find the coordinate of the midpoint. So from point C at -4 to point E, 2. Now, kind of already see here as far as the distance between, we've got a distance of 4 plus 2, so that's 6 total units. You could also do -4 minus 2, do the absolute value, or 2 minus a -4 to the absolute value. Either way, you'll end up with a distance of 6. I'm sure it shouldn't come as a big surprise that if the whole distance is 6, halfway should be 3. And if you go 3 units this way, or 3 units that way from C to the right, or E to the left, and of course simply using the formula, which I would argue is the best approach. Nonetheless, -4 plus 2, right? -4 plus 2 divided by 2, so you're averaging -4 plus 2, which is -2 halves, -1. So -1 in fact is halfway between 3 units to the right, but also 3 units to the left of the 2 endpoints, C and E. BG is the next segment we're going to find the midpoint of, number 6. So B is at -7, G is at 8, -7 plus 8 divided by 2, in other words 8 minus 7, which is 1, divided by 2, so we've got simply 1/2 right here roughly as the midpoint between this point B and that point G. Moving on, we've got 2 more to take a look at. Number 9, A is at 0, 0, B is at 12, 8. Again, if you were to put this on an XY axis, you would add 0 and 12 divided by 2 to get 6, 0 and 8 divided by 2 to get 4. 6, 4 is in fact halfway between 0, 0 and 12, 8. You're not always going to get a nice ordered pair. Obviously, on number 12, for example, from E to F, E is this point, F is that, -2 plus -9, take the average or divide by 2, you get -11 halves, and then 6 plus 3, that divided by 2, 9 halves. That ordered pair again is halfway between E and F precisely. Take a look at the graph and maybe you'll be able to clearly see that and it make more sense in that particular regard. Try some of these other questions to give yourself practice. The homework is listed nonetheless.